1.5b, analyzing graphs. So in America, which way do we read? Left to right. So if the function is going down from left to right, that's called a decreasing function. If it goes straight across, it's called a constant function. And when it goes up from left to right, it's called an increasing function. All right. So what kind of slope does a constant function have?
Horizontal.
It's a horizontal line, true that. But what kind of slope is it? It's a zero slope. If it's a decreasing function, what kind of slope does it have? Negative. If it's an increasing function, what kind of slope does it have? Positive. All right. So the first one I have is this graph right here. And I need to work with the x values of it to tell me when it's increasing, decreasing, or constant. I'll do part A. So do you see how it's going? It's going up, right? So we call that what? Increasing. So this is actually increasing from negative infinity, which means all the way left, to 0. And then it increases from 0 to infinity. This year I will actually accept negative infinity to infinity on that one. However, at 0, it's actually perfectly tangentially horizontal. All right? But I would accept negative infinity to infinity on that one. This next one, I need some help. Let's see here. Ryan, can you help me out on this one? When is this function increasing?
When?
Yeah.
Negative infinity to negative 1.
Negative 1, good. All right, when else is it increasing?
1 to positive infinity.
Perfect, great job. All right, and Cade, when's it decreasing?
Negative 1 to 1.
Good. All right, Cade calling somebody.
Christopher James.
All right, Jones, part C. When is this thing increasing?
Negative infinity to positive 1.
Not positive 1. We're going to do the x values of it.
To 0.
To 0. So negative infinity to 0. And then, when is it decreasing?
2 to negative infinity.
2 to, not negative infinity. It's actually going to the right. So we're going to call that positive infinity. And then when's it constant?
From 0 to 2.
0 to 2. All right. Now we have relative mins and maxes. A relative minimum is kind of like the valley. All right. It's when the function goes from decreasing to increasing. Decreasing to increasing is our relative or local minimas. All right. A relative maximum is when it goes from increasing to decreasing. So that's a relative or local maximum. So I have this lovely little graph. All right, and I'm going to ask what my decreasing, increasing constants and my relatives are. All right, so Cooper, help me out. When's this bad boy increasing?
It is increasing from negative infinity to negative 2.
Good. When's it decreasing? We have more, don't we?
Yeah.
When else is it increasing?
It is also increasing from 1 to 3.
Good. All right. When's it decreasing?
It is decreasing from negative 2 to 1.
Good. All right. And when's it constant?
3 to positive 50.
Good. All right. And then let's talk about our relative mins and maxes. So let's do our relative minimum first, and then let's do our relative max first, or next. All right. So our relative minimum would be the ordered pair of what? Daniela, where's my relative minimum?
1, -2.
Good. And then my relative maximum would be at what?
-2, 3.
Good. All right. Now, it is a little bit different here. These increasing, decreasing constants are actually intervals. Okay? And these are actually what? Ordered pairs. All right? They look very similar. However, this is interval notation. This is an ordered pair or coordinate system. Okay? Average rate of change. This is what you've been doing your entire life, is an average rate of change. All it means is its algebra slope. All right? y2 minus y1 over x2 minus x1. It's really a slope of a secant line. Because a secant line goes through how many times? Twice. It goes through twice. So it's just algebra slope, y2 minus y1 over x2 minus x1. Or, because of Leonard Euler, we have this notation of f of x going on. My function here is x cubed minus 3x. And I need to find my average rate of change from x equals -2 to x equals 0. But what do I need to find a slope? I need the y's. So, what do I need to do? Please don't curse. Substitute, thank you. Ooh, I got scared for a second. So I need to substitute that in to my function. So now I need to have f of -2. So I'd have -2 quantity cubed minus 3 times -2. So -2 quantity cubed is -8. And then -3 times -2 is +6. So -8 plus 6 is -2. So my ordered pair would be -2, comma, -2. All right. And then I need to find from f of 0. So f of 0 is what? 0 cubed minus 3 times 0, which is 0. So that ordered pair is 0, 0. All right. And then an average rate of change. So my slope would be 0 minus a -2 over 0 minus -2. So I end up with what? 1. I end up with 1. All right. Part B. Now I need to go from 0 to 1. Well, we already found 0. What's the ordered pair there? 0, 0. And now I need to find f of what? F of 1. So what is f of 1? One cubed is 1. 1 minus 3. So we get -2. All right, so now I have the ordered pair 1, -2. So now I just find my slope. So now I have -2 minus 0 over 1 minus 0. So I end up with -2. All right. We're going to read. Here we go.
The distance x in feet a moving car is from a stoplight is given by the function s of t equals 20x or 20t
To the 3/2 power.
to the 3/2 power, where t is the time in seconds. Find the average speed of the car. A from t1 equals 0, t2 equals 4 seconds, and b from t equals 4 to t2 equals 9 seconds.
All right, fantastic. So I need to find average speed, so I need to find algebra slope of position. So I need to find ordered pairs first. So what are we going to do with 0 and 4? Substitute it in. So now I find s of 0. So I have 20 times 0 to the 3/2 power. Well, what is 0 to the 3/2 power? 0. 0 times 20 is 0. So my ordered pair is 0, 0. And then I need to find s of 4. So now I have 20 times 4 to the 3/2 power. Well, this one, how to work with the 3/2 power or fractional power. First, you do the lower one. So this 2 on the bottom is really like a square root. Okay, so 4 square rooted is what? 2. 4 square rooted is 2. And then you do 2 cubed, which is 8. And then you have 8 times 20, which is 160. So now I have the ordered pair of 4, comma, 160. So I now have my ordered pairs. To find my average speed, I just do algebra slope. So now I have 160 minus 0 over 4 minus 0. 160 divided by 4 is 40 feet per second. All right. So on S of 9, you do 9 square rooted, which is 3 cubed, which is 27. 27 times 20 is 540. And then you do your algebra slope, so 540 minus 160 over 9 minus 4. You end up with 76 feet per second. Pretty good in the hood? All right. Enjoy. Have fun.